Assalamualaikum, my name is Sarahani. I'll be explaining the standard plan and the calculation behind the plan. So for the first phase, we have the requirement specification review. So what is POD? POD is phase originated defects, and FE is filtering effectiveness, and CDR is cost defect removal. So these three quantities are given and fixed. So the POD of the phase is 15 given from here. And the PD of this phase is 0 because what's PD? PD is past defects, and since this is the first phase, therefore there's no previous defects from this phase, so that's why it's 0. And the filtering effectiveness is 50 given from here. From here. So what RD is the remove defect. So how do we get the remove defect? Is you total up the POD and the PD, and then you multiply it by 50. So 15 plus 0 is still 0. And you multiply it with 50, divide with 100, you get 7.5. And that's how you get the remove defect. And the CDR, which is given, is 1. So you will have to multiply the RD with the CDR, then you get the TRC, which is the total removal cost. So for the next phase is design review. We have the POD, which is 35. From here, we have the PD, previous defect. So how do we get the previous defect? Is you subtract from the total of POD and PD with the remove defect. So 15 subtracts with 7.5, you'll get the 7.5. So that's how you get the previous defects. And for the FE is 50% given from here to 35 plus 7.5. You get 42.5, and you multiply it by 1 over 2. We have 21.25. So based from the calculator, we have 21.25. We just have to round it into one places, then you get the 21.3. Next is CDR. CDR from here we have 2.5, and that's where you get it. So from there you have to multiply it with the RD, you get 2.5. You get 53.125, round it, and then you round it, you get 53.2. So for the next phase, we have unit test. The POD given is 30% right here. So how do we get the PD? Is like I mentioned from the previous phase, you have to total up with the POD and PD. Then you will subtract with RD, which is the remove defect. So that's how you get the previous defects. So let's calculate it. Plus with 7.5, 42.5. Subtract with RD from the previous phase, and you will get 21.2, which is here. And the defects given, the filtering effectiveness given is 50%, same. So how do we get the RD? We're gonna plus it with the POD. You'll get 51.2, then we will multiply it with half. Then you will have the 25.6 for the remove defects, and the CDR given is 6.5. So the TRC of it is 166.4, where you have to multiply it with the RD with the CDR. So for the next phase is integration test. The POD given is 10. And the previous defects is 25.6. So this is how you calculate it. 30 plus 21.2. Then subtract with the RD. And that's how you get the previous defects. The filtering effectiveness given is 50%. And the RD, the remove defect, is the total of the PD and POD. Oh, my bad. Let's start it all over. 10 plus 25.6. We have 35.6. Divide by 2. You get 17.8 for the remove defect. The CDR given is 16. Then you will multiply it with 16. And that's how you get the total removal cost, 24.8. For the next phase is documentation review. The POD given is 10, which is the last of the characteristic. distribution of the origin wax. The last phase originated, yes, the PD, and the PD was 17.5, so 10 plus 25.6, subtract with 17.8, we still get 17.8, and the filtering effectiveness given is also 50%. So plus with 10, you get 27.8 divided by 2. We have 13.9, and the CDR given is 16. Therefore, you have to multiply it. You'll get the 222.4 for the TCR. The second last phase is a system test. The POD was not given in the reference, therefore it's 0. And the PD is 13.9. Like always, 10 plus 17.8. Then you subtract with 13.9, you will still get the 13.9. So just for the sake of presentation, I will just show it. Yep, still 13.9, and the filtering effectiveness is 50% again, and divided by 2, you get 6.95, and you round it by it, you get 7, and multiply with 40, yes, and that's how you get 280 for the TRC. I think I said it wrongly in the previous. So for the last phase is the operation phase. Since the POD was not given in 0, the PD was 6.9. So 13.9 subtracts with 7. We have 6.9. The filtering effectiveness is 100% given from here. And the CDR, wait. So 6.9 is basically just multiplied with 1, we still get 6.9. For the RD and CDR, you have to multiply with 110 given here. You will get 756 for the TRC, for the whole total. And that's it for me. Thank you.
Hi, my name is Aimi and I will be explaining about the mini plan. So from the question here, there are only 2 phases in the mini plan that have filter, which is first is the design review, 50% filter effectiveness, and second is the system test, 60% filter effectiveness. So this is the mini plan. So other than these 2, design review and system test, the filter effectiveness is 0. Here is 0, 0, 0, 0. So before we start, the phase originated defect and the cause of defect removal, the value is fixed. We can refer this from the slide. This is the phase originated defect or POD. And the CDR, cause of defect removal, we will refer to this slide. So we will be referring to them throughout the explanation. So first we start from the requirement specification. So the phase of defect removal is 15. And the past defect, there is no, this is the first phase, so there is no past defects yet. So it is 0. So the total of defect here is 15. And the filter effectiveness is 0. So the removed defect is also 0. The cost of defect removal is 1. And the total removal cost is 0. So we move to the next phase, the design review. So the phase originated defect is 35. Okay. So the past defect from the requirement specification review is 15, and the filter effectiveness is 50%. So the total defect here is 50. Multiply with 50% effectiveness, filter effectiveness. So we got 25, and the cost of defect removal is 2.5. So total removal cost, 25 multiply with 2.5, we got 62.5 cost per unit. So then we move to the next phase, the unit test. The phase originated defect is 30. So the past defect here is 25. So how do we get 25? The total of defect here, 50, minus with the removed defect, 25. So we got the 25 here. So the filter effectiveness is 0. Removed defect is 0. The cost of defect removal is 6.5. And the total removal cost is 0. So the total defect in this phase is 55. So in the next phase integration test, the phase originated defect is 10. The past defect is 55 from the unit test. So the total of defect here is 65. The filter effectiveness is 0. So the removed defect is 0. The cost of defect removal is 16. Here's 16. And the total removal cost is 0. So we move to the next phase, the documentation review. The phase originated defect is 10. Here, phase, the documentation review, phase originated defect is 10. So the PD, past defect, is 65 from integration test. And the filter effectiveness is also 0. So remove defect is 0. CDR, cost of defect removal, is also 16. And the total remove cost is 0. So the total of defect here is 75. So we move to the next phase, the system test. So the system test, there's no phase originated defect. So the value is 0. But the past defect from the documentation review is 75. And the filter effectiveness is 60 that we got from the question. So total defect 75 multiply with 60% filter effectiveness, we got 45 here for the removed defects. And the cost of defect removal is 40 for the system test. So the total removed defect 45 multiply with 40, we got 1,800 cost per unit. So we move to the next phase, operation phase. So operation phase, it also have no phase originated defect, so it is 0 here. And the past defect from the system test, we got 30. How do we get this? 75 total of defect minus with removed defect. So 75 minus 45, we got 30 here. And the filter effectiveness for operation phase is 100%. And the removed defect 30% at 30 multiply with 100%, we got 30 here. And cost of defect removal here is 110. So total removal cost 30 multiply with 110, we got 3,300 cost per unit. So the expected saving. So the question is the expected saving, if any, resources invested for defect removal during the development process using the proposed mini plan as opposed to the standard quality assurance plan. So the expected saving of resources is 25% at 22,541 if we use the standard quality assurance plan. So how do we get 2,541? 3,000 here. The 3,300 cost per unit. We compare with the standard plan here. So the standard plan cost, total removal cost is 759. So 3,300 minus with 759, we got 2,541.
Assalamualaikum, my name is Nurfatini. So for question number 4, some of the suggestion for general rules about choosing the preferred quality assurance plan is: number 1, start early for cost savings. Quality checks should start early in development when fixing mistakes is cheaper. This will reduce the number of hidden issues that make it to the final test. For number 2, more diversity equal to better results. Doing various quality checks help catch different kind of problems. This cut down on the number of issues that make it to the final test and reduce the percentage of defects. For number 3, which is the last, we should invest in early quality. We should put extra effort into quality in early development phase to catch and fix more problem when it's easier and cheaper, so it will save us from more defects